safety message to you via seminars, workshops, and videos using our aviation safety team representatives, which means our production crew is made up almost entirely of volunteers giving their time to support aviation safety. After today's presentation, please reach out to the folks that you see that are doing the work, our crew, the camera people, the stage people, the floor people, and let them know that, you know, all their efforts and time is really worthwhile and appreciated. Now, our next presenter is member Earl F. Weener. He is has an accomplished career in aviation as an engineering executive with safety advocate, industry, safety spokesperson, engineer, and pilot. He has given numerous presentations on aviation safety in airline operations, as well as corporate, business, and general aviation safety. Most recently, he was a foundation fellow for the Flight Safety Foundation, where he led the international industry teams to develop means to reduce accidents through coordinated industry programs in areas such as ground operations and runway incursions. I'd like to present to you from the NTSB, National Transportation member, Earl F. Weener. Let's give him a round of applause. Thank you.
Good. Thank you, Vicki. So 8:30 on Saturday morning. This is the hardcore group. I'd like to talk a little bit about the NTSB, the things that we're doing to improve general aviation safety and why. And by way of let's see, where's the clicker? Right here. No, that isn't it. Oh, hit the space bar. Just do the use.
Where is the clicker?
Okay, it looks like we're going to have one slide here for the whole presentation.
Okay, let me see here.
As Vicki said, I've been in the general aviation industry since mid-'60s when I first got my first private license. And actually I've kept a flight instructor rating active and current pretty much that whole time. By way of introduction, previous years I've managed to come up with a good excuse to fly the Bonanza down here. This is my airplane. I chose this picture because this is when I bought the airplane, and the airplane looks as good as it did then, but I got a whole lot more gray hair and less of it overall. And I look 10 years younger in this picture. Let me start with a few words about what the NTSB is. We're not the FAA. We don't give anybody violations. We don't have any regulations to manage. We don't do policy, but what we do is investigate accidents, determine what caused the accident, the circumstances, analyze the accident so we really understand how to prevent it from happening again, and in so doing come up with recommendations for how to improve general aviation safety or transportation safety overall. We're a relatively small agency by Washington standards, about 420 staff, 5 board members. The board members are each appointed by the president, confirmed by the Senate. So we're not the folks in the black hats, we're the folks in the white hats. You're not likely to meet us unless you have an accident, or if you come to an event like this, or if you participate in any of our advocacy activities, and I'll talk a little bit about those in the future. The topics I'm going to cover today are the accident trends, which really define why general aviation safety is important and why doing something more about it is important. One of our ways to accomplish advocacy is our most wanted list, and so I'll talk more about that. That covers all of transportation safety, but in particular, general aviation is on the top of that list. Then I'll talk about some things that are going on within the industry, particularly the Joint Steering Committee, the JSC. It's an industry government activity, both sectors working together to come up with consensus-driven improvements to aviation safety. And finally, talk about some of the NTSB activities. So let me start with general aviation accident trends. We investigate about 1,500 accidents a year currently. These are all general aviation accidents, Part 91. It looks like it's a good news story in that it went from over 1,800 to a little over around 1,500 in 2012. About 1 out of 5 GA accidents involves fatalities. If I just look at the number of fatalities, the number of people who die in general aviation accidents, that also has gone down from 600 to about 426 over the basically 12-year period. Again, sounds like a good news story. Unfortunately, the number of flying hours has gone down more than the accidents have. So the accident rate has not improved. This, in fact, is the accident rate for general aviation overall. The top one is all accidents, the bottom one is fatals. So on the average, you have about, we in this community have about 6 accidents per 100,000 flight hours. About 1.5 to 1.25 fatal accidents per 100,000 flight hours. Now, what do we see as the defining accidents? Well, loss of control is the top. And I'll talk more about loss of control as we go through the presentation. System and component failure, basically power plant failure, is the second highest category. Controlled flight into terrain, namely flying a perfectly good airplane into the ground under control, is number 3. Then collision with terrain or an object but not CFIT. VFR into IMC, that's a real killer. And component failure, non-power plant. So let me show you what the accident rates look like if I start peeling it down to the various sectors. We'll look at all of the 5 different sectors here, or 4 sectors in the average. So this is that average that I showed you a moment ago. This is all accidents. This is where corporate lies. Corporate operations are very safe. That's an accident rate approaching that of the airlines. Not surprising in a sense that it's so safe because you're flying generally turbine aircraft with a professional crew, 2 crew members, recurrent training, often dictated by the insurance companies. Very sophisticated operations in many cases. Business flying, which means flying an aircraft for business purposes, but not by a professional pilot or not by somebody who's employed only to fly the airplane. Instruction is a little bit below average. Now, if everything is below average, and all we have left really is personal flying looks like that. It's gone up 20% over the last decade. Not the direction that we would like to see things change. If I look at the corresponding groups in terms of fatal accidents, here's that fatal accident rate that we saw before, a little over 1.25. So there are some years where corporate doesn't have a fatal accident. Business flying has been improving. Instructional flying is right in there with business flying. Not surprising, because most instructional flights have somebody with a commercial license sitting in the right seat giving the instruction. But fatal accidents for general aviation, personal flying, has gone up 25% over that time period. So that's the reason for the focus on general aviation safety. So, as I said before, a most wanted list is the way we do advocacy. Since we can't make anybody do anything in terms of make changes, we're dependent on having the opportunity to explain our case, twist a few arms, use a bully pulpit now and then. So the most wanted list is one of the ways we do that. We've had a most wanted list at the NTSB since about 1990. About 3 years ago, we revamped it a bit. So we have now a top 10 most wanted. And that top 10 changes every year. We, as board members, decide which are the top 10 safety activities we'd like to promote. So the most wanted list for this year, as I said, general aviation is on the top. Now, actually, I rearranged them so it's on the top, but that's my prerogative since I'm speaking here. The past 3 years, we've focused just on general aviation in a broad way. This year, we've now focused it much more narrowly. We're talking about identification and communication of hazardous weather. And I'll give you some examples of that in a moment. Here are some of the other areas: helicopter operations, passenger vessel safety. Each board member has 2 of these areas, and I just happen to have general aviation and passenger vessel safety. I'd much rather talk to a general aviation crowd than the passenger vessel folks, however. Distraction in transportation. You've been hearing a lot about cell phones and texting in automobiles, but in fact that's a problem all the way across the industry. Transportation. Eliminate substance impaired driving. In the past, that's been a focus on alcohol impairment, but drug impairment now is becoming almost as big an issue. Pipeline safety, fire safety in transportation, positive train control systems, operational safety in rail mass transport, and occupant protection in transportation. The one I'm going to concentrate, though, on is the top one: identification and communication of hazardous weather. So why on the most wanted list? As I said, we investigate about 1,500 accidents a year. Overall, the accident rate for general aviation is flat. During that meantime, by the way, while GAs have been flat or personal flying has gone up, if we look at the Part 121, the air carriers, also known as the airlines, they've reduced the accident rate by 80%. 80%. Until the Asiana accident in San Francisco last July, there hadn't been a fatality in commercial airlines in the U.S. for 5 years. To put that in perspective, we kill about 35,000 people on roads every year. So the airline flying is extremely safe. And the means that the airline community has used to achieve that kind of accident rate is something we're trying to parrot, that we're applying in the general aviation area, and I'll talk more about that. So the personal flying accident rate's gone up by 20%. Fatal has gone up by 25% over the last 10 years. So why focus on weather? Well, I'm sure all of you have had some sort of scrape with weather over the years. I have. But there are a lot of different reasons for why we get into trouble with weather. Not all of them are our own faults. But most accidents or incidents in weather can be prevented. Here's a breakdown over a 3-year period, Part 91, of weather-related accidents. Adverse wind accounts for half of the accidents. As you'll see in a moment, however, adverse wind is not very fatal. Adverse wind causes runway veer-offs, losing control on the runway, tailwind landings, but the real killer is low ceilings and visibility, which is 18%. So almost a fifth of the weather-related accidents are low ceiling and visibility. Then you see some of the others: density, altitude, carb icing, turbulence, and so forth. So what we're going to concentrate on are the first few. As I said, adverse winds account for most of the accidents, but they don't account for anywhere nearly the majority of the fatalities. Reduced visibilities account for about, well, 2 out of 3 reduced visibility accidents are fatal, involve fatalities. Even more so for low ceilings. I think AOPA has a figure that when a VFR pilot flies into IMC conditions, life expectancy is about 126 seconds or something of that order. Gives good reason for getting some time on the gauges. So weather-related accidents can have very high fatality rates. So the areas of concern that we're focusing on in this year is the overall ATC pilot and meteorology culture. And by that I mean there's a fair amount of misunderstanding about the various roles and capabilities and attitudes between those 3 groups. Talk a little bit about weather training, National Weather Service consistency and aviation information products, and PIREPs. But let me start with looking at an accident. This happened August 2012. It was a Bonanza on an IFR flight plan. Had gotten a weather briefing. This is one of those weather-related accidents where we can actually interview the pilot afterwards. So the setup on this is there were severe weather, some severe weather in the area. You can see the white dots are lightning strikes. There were over 2,000 lightning strikes in the 20 minutes before the accidents. You can see his flight path went through some pretty crummy weather. The weather looked like this from a 3D perspective, and he flew right through that big chunk of weather. Just some different views of the same thing. In the middle of it, he lost his propeller. That's the spiraling down. He did manage to land in the field. Everybody walked away from that one. But the point here is that when he approached the weather, he told the ATC, because he was on an IFR flight plan, he told ATC that he had weather radar on board. So ATC said, oh, if you've got weather radar on board, you probably know better about the weather conditions than I do, because I don't really trust my big elaborate console. And so the ATC stopped giving him weather advisories, figured, well, he's good to go on his own. The pilot assumed that ATC would never let him fly through something like that without helping him to avoid it. So here's a good case of misunderstanding. The pilot thought ATC had better weather capability. ATC thought the pilot had better weather capability. It's not the first time that we've seen this kind of problem. Let me take another accident. This was a Cherokee 6. The accident happened in 2011 in December. The pilot was on an IFR flight. We're not able to determine whether they had a weather briefing because there was nobody to interview afterwards. All 5 occupants died in the accident. At the NTSB, we're almost obligated to show you some wreckage, but this is the kind of things that our regional investigators see every day. Just a side note, we have about 55 people who are regional accident investigators for General Aviation. These people are scattered around the United States to some extent so that they are close to, or somebody will be close to where an accident happens. So this is the wreckage looking forward. So one side, the other side. By the way, not all of the wreckage was in the same place. It was strewn over about a half a mile distance, a couple of 100 feet wide. A little data on the flight. It was a cross-country flight with 4 passengers from Jackson, Mississippi to Waco, Texas. They were level at 8,000 feet. The pilot informed ATC he was diverting around an area of thunderstorms. This guy had onboard weather, NEXRAD weather, and he was using it to pick his way around buildups. The last transmission he had was he told ATC he was in bad weather and he was going to try to get out of it. Shortly thereafter, radar and radio contact was lost. As I said, the wreckage was all in one place except for the left wing, vertical stabilizer, rudder, and the right tip fuel tank. The left wing spar showed wing failure in a positive overload, so it's an in-flight breakup, high Gs. The airplane had no particular problems that we could identify pre-impact. Reasonably high airframe hours, 6,000 hours. Pilot had a private license, single engine land rating, instrument rating, less than 400 hours total time, and only 14 hours on actual instruments. So 14 hours actual instruments, and he's trying to pick his way through a line of thunderstorms. The weather conditions were such that there was a segment describing the potential for heavy rain showers, thunderstorms, high winds, clear air turbulence, low-level wind shear. But he's working his way around this kind of weather with a Garmin 696 with XM NEXRAD weather. Now, I love XM NEXRAD weather. I have it in my airplane. I would feel a bit naked trying to make any sort of a long flight without having that weather, but there are limitations. The NEXRAD data showed that the pilot was clear of precipitation, but he flew into a rapidly developing rain shower. This is what the pilot saw. This is the weather he saw, and you can see the X marks the spot where the accident occurred. He thought he was in light rain. This, however, was what the weather really was, and he was in the middle of a red cell. You have to remember that the NEXRAD date or time shown on the display is the time that that image was compiled and sent forward. Doesn't include the time that it takes to pull all of the radar data, build the mosaic, then send the mosaic over to the transmitter, and then the time starts. So you can find in some cases that weather is 15 minutes old, or some part of your mosaic image can be 15 to 20 minutes old. So as I like to make sure everybody understands, NEXRAD mosaics are really great. They show where the weather was, not where it is. So give yourself a berth around weather at least as good as the rate at which thunderstorms move. That led to a safety alert and we'll talk more about safety alerts, but a safety alert related to the use of neck thread or in-cockpit weather. Okay, let me talk a little more about pilot reports. Pilot reports, I don't know how many of you are adept at giving pilot reports. They're really very useful. They're more useful than what I really understood until I got involved with this activity on the most wanted list and had my eyes opened a bit. PIREPs allow ATC and the meteorologists to understand what's really going on. Are their forecasts accurate? Are their forecasts, is the weather worse than forecast or better than forecast? And what I didn't understand and now do is that a pilot report which says, gee, we're in the clear, we're having a great ride, we're at 6,000 feet, unlimited visibility, is really useful. I figured that that was just a waste of time. That may be the kind of information that the weather meteorologists use to say, gee, we missed up on our forecast. They're also used by the meteorology folks to help sharpen the size of airmits, segments, and so forth. Without pilot reports, sometimes the Weather Service is just stuck in making a big block of four-sided block of weather covering at least 3,000 square miles. That's the minimum size they can make unless they've got better data like pilot reports. So this is an example of a typical day. You can see by the number of pilot reports of turbulence along the line from basically Louisiana, Oklahoma, Arkansas, on up to New England, that there must be some weather going on. But if you believed that pilot reports were accurate, gee, there's no weather in Montana, no weather in Oregon, well, a little weather in Oregon, no weather in Washington. In other words, the null pilot reports would have been useful to confirm that, in fact, that weather was good. So we've got to focus on improving pilot reports or making people understand the utility of pilot reports, PIREPs. We are working this activity with AOPA, with the FAA and the National Weather Service. So it's government and industry working together, which is the theme I'll talk about in more detail in a moment. So what happens when you give a pilot report? Well, it can go to ATC or it can go to Flight Service. That's Lockheed Martin Flight Service on the right. Where does it go after ATC's got it? Well, it goes no place. I think we have another failure here. Oh, okay, there we go. Once it's in ATC's hands, it can go to the supervisor for dissemination. It can go to the CWSU. Anybody know what CWSU is? Center Weather Service Unit. There are weather units in all of the centers that coordinate between the National Weather Service and the ATC folks. And in fact, there's a fair amount of expertise in weather in the centers. In the new aviationweather.gov, you can get at CWA, Center Weather Advisories, and they're quite useful. Flight data is data transmitted between the centers. So you give a report to ATC, it can go to any number of places. Sometimes it goes in a circle. Eventually, it ends up at some meteorologist or some national airspace system or in weather products. But what we would like to see in the future is a lot more direct pilot reporting, and that may be taking the form of an automated pilot reporting system Many of the large carriers, the air carriers, in fact, already have systems that report weather as they're flying along back to their own weather units in the dispatch in their ops centers. So make sure to understand that pilot reports can be the best weather information for ATC pilots and meteorologists. Give pilot reports, report weather that does vary from what is forecast as well as weather that doesn't vary. And null reports that it's severe, clear, and no turbulence are also useful. There's information in the Airman Information Manual on making pilot reports. In particular, the reports on icing and turbulence are extremely helpful. And AOPA has a course on pilot reporting. This is the address, but you can find it through their homepage. Okay, we've put a high importance on identifying and communicating hazardous weather, put it on the most wanted list. This will be a multi-year project. We're working it in cooperation with ATC, with the National Weather Service, with members of the industry. So let me talk now for a few moments about some of the community activities that we're doing, and particularly the Joint Steering Committee. Now, I said earlier that air carriers have reduced their accident rate by 80, actually it's more like 83% over a 10-year period. You know, about a dozen years ago when we set that goal, we all kind of looked at each other saying, this is preposterous, but you know, let's make a stretch goal. The means used to improve safety have been an activity called CAST, Commercial Aviation Safety Team. CAST is a large group working together. The airlines, the FAA, the NTSB, NASA, the labor unions, airports, basically the whole airline operational and equipment community has been working together. They use a process whereby they use data to identify where the real problems are. They use analysis to figure out what they could do, and if they did it, what kind of difficulty would it be to do it? And again, if they did it, what kind of improvement would they actually make? And then once they do it, they have feedback to find out how effective what they did was. Now, this activity has been going for almost a dozen years, and it's been very effective. We're doing the same thing in general aviation. So, as I said, we're following the CAST model, so data-driven risk management, consensus decision-making, voluntary commitment, and implementation focused. That voluntary commitment is an important part to mention. This improvement in the airline community operation has been done without a single regulation. Or if there has been a regulation, it's just been a cleanup regulation to make sure everybody does it. So it's been done without the heavy hand of the FAA. There is, in fact, a kinder, gentler FAA lurking off to the side, and we're taking advantage of that. You're welcome. So there are three major parts of the Joint Steering Committee, the JSC organization. The top is the Steering Committee. That's co-chaired by the FAA and AOPA together. There's Tony Fazio from the FAA and Bruce Landsberg from AOPA. The work starts with the Safety Analysis Team. That's co-chaired by the FAA and the General Aviation Manufacturers Association, GAMA. This is a team that digs through the data and identifies where the real potentials are for making safety improvements. Then once that's been decided upon, a working group is formed, and that working group is composed of the subject matter experts in those areas. So I'll talk in a moment about the first of our working group's products. The participants in the government side, as I said, FAA, NASA, NTSB, National Weather Service. And in the industry and the operational community, there are more alphabet groups than what one can really identify and remember. But General Aviation Manufacturers, the Experimental Aircraft Association, National Business Aircraft, National Air Transport Association, which is basically Part 135 operators and FBOs, AOPA, the training community, SAFE and NAFI, the Flight Safety Foundation, then we get into the University Aviation Association, Pegasus, and so forth. We also include insurance. So it's a very broad group. We try to compose the group of people who can actually make things happen. So how do we go about this? Let me show you. If we look at business flying for a 5-year period, now this is business flying, which was kind of on the low end of the accident rate, if you recall that one of the earlier charts where I had them all broken down. These are fatal accidents. Loss of control, there were, in that 5-year period, 13 fatal accidents. 7 controlled flight into terrain, and then some fuel management, power plant failure, and then you're down to singles. But loss of control is the top bar. Now, if I look at instructional flying, there are 47 accidents in loss of control, fatal accidents, during a 5-year period. So that's about 10 a year. Controlled flight into terrain is 7, midair is 7. Midair is not a surprise since a lot of the training activity occurs in training areas and in the pattern. So there's a concentration of airplanes in training. Remember, there were, what, 14 accidents for business. There are 47 accidents for instructional flying. And there are 444 accidents in loss of control for personal flying. That's almost 10 times as many as instructional flying. By the way, engine failure is about 1/4 of that amount. So 103 power plant failures. Control flight into terrain and on down the list. Actually, over my career, have been really focused on working the big bars. Focus on the big bars and work on the big bars until some other bar turns out to be bigger. By the way, this is not just a problem for general aviation. This is a little bit different count. I was talking about number of fatal accidents. Here we're talking about number of fatalities, but the number of fatalities, and this is from Boeing's data for large transports. The big bar there is loss of control. For a 10-year period there, worldwide, it accounted for 1,600 fatalities. So, personal flying, it's loss of control. Instructional flying, loss of control. Business flying, loss of control. You see a pattern here? So that brought us to comparing all of the various groups. Personal flying with 444, instructional flying, and business flying. So personal flying, that's the kind of flying that most of us in this room do. And that's our big killer. So as Joint Steering Committee, the first activity that we focused on was loss of control. We put together a working group. The working group went away, came back with a whole bunch of safety enhancements, which then were evaluated for being practical and productive. And the top of that list is angle of attack for all aircraft, new, current, production, and retrofit. Then down the list, aeronautical decision making. A lot of loss of controls are just bad decisions. Some are stabilized approach, single pilot CRM. Interestingly, we keep finding sedative medications in pilots' bloodstreams in accidents. And at some point, it almost looks like 1/4 of the accidents have some sort of medication effect. and then weather technologies. All in all, there were 28 safety enhancements that were identified. So angle of attack, that's a nice idea. But an angle of attack indicator, if you want to buy a certified angle of attack indicator, one that meets the TSOs, the technical standards orders, and put it on a certified airplane, costs 10 grand or more. If you want to put it on an amateur-built experimental aircraft, you can get the parts for less than $1,000. When I talked about the kinder, gentler FAA, recognizing the importance of angle of attack, and in fact, angle of attack is the only thing that's important when it comes to stalls. And most loss of control accidents involve stalls. The wing only knows angle of attack. It knows very little else. It doesn't care about pitch attitude. It doesn't care about glide path. It only cares about angle of attack. And it only cares about it with regard to that curve that you see in the lower right, which is the lift coefficient with regard to angle of attack, and stall is that topmost part. Beyond stall, the more you increase the angle of attack, the less lift you get. So it was recognized that angle of attack was valuable. It was also recognized that putting angle of attack information in an airplane that didn't have it would improve the safety of the airplane, improve the safety of the operation. So how do you get that kind of thing installed, since it's not a required item for that type certificate? Here's where having the FAA involved, and in particular the Small Airplane Directorate is a member of the steering committee, the steering team. The Small Airplane Directorate has come up with a change in policy to allow an angle of attack system that is approved by the FAA, but approved by the FAA means, in this case, it meets FAASTeam standards, and the manufacturer certifies that it's been built to FAASTeam standards. Then the angle of attack indicator can be installed by a mechanic as a minor mod and signed off in a logbook. It is not a major mod anymore. So it can just be put on, signed off by the mechanic. So it now is a couple of hours of mechanics time and less than $1,000 of parts, and you can have an angle of attack indicator. This is a policy change I think we're going to see more of within the FAA when it comes to general aviation, because there are a number of safety systems and safety enhancements that could be made but aren't made because of the difficulty in certifying them and putting them on an airplane which was certified to begin with without them. So it's a positive increment in safety. So let me finish off by talking about some NTSB activities. On each of every other seat, I laid a set of 5 safety alerts and some video, a disc of DVD, a DVD rather of videos. But let me tell you what they're all about. As I said before, we've got 55 regional investigators, and that's, by the way, the biggest chunk of our single biggest chunk of the aviation of the NTSB, actually, in terms of investigators. These folks keep seeing the same thing over and over again. So they put a team together. They got motivated to say, we need to figure out something we can do. So they came up with safety alerts. The subjects are preventing aerodynamic stalls. This is loss of control. Reduce visual references. This is like VMC and VFR and IMC. But that also is a loss of control accident often. Then is your aircraft talking to you? Many of you who fly your own aircraft or the same aircraft over and over again realize how sensitive you can get to things being a little bit different. Then risk management for both pilots and mechanics. So these took the form initially of safety alerts. They brought them to the board approved them. But not to be outdone, these folks decided that what they would like to do is put them into a video. Each one has their own videos. So if we can get this to work.
As an aviation safety professional, I've seen firsthand what can happen when a pilot doesn't take an aircraft anomaly seriously. And I know a lot of pilots might look at these maintenance-related accidents and think to themselves, well, that would never happen to me. I'd never put myself in that situation. But personally, as an aircraft owner and a pilot, when I look at these accident scenarios, I can completely understand how some of these pilots found themselves in these situations.
As an investigator and a GA pilot, nothing pains me more than to see pilots, their friends, and their families lose their lives in accidents that are completely preventable. Low-altitude stalls are just that, completely preventable. From day one in pilot training, we're taught to recognize and recover from stalls, and to never turn back to the field after an engine failure, because that could lead to a stalled condition. But at some point, as pilots, we stop training for those situations. We don't stop flying, but we stop training.
No one wakes up in the morning and thinks they're going to be involved in an accident. Many of these pilots who crash their airplanes fail to appreciate their own limitations. There are multiple resources out there available to these pilots, like the DECIDE checklist, the I'm Safe checklist, or the PAVE checklist, which can help these pilots make good decisions.
In 2007, a private pilot who had recently purchased an airplane was attempting to return home on a cross-country flight. After encountering a delay due to mechanical difficulties, the pilot elected to continue the flight into the evening hours, despite the fact that he did not hold an endorsement to fly at night. The pilot subsequently encountered reduced visibility in rain, lost control of his airplane, and crashed.
If every mechanic could spend some time as an air safety investigator, I believe that those experiences would remain with them for a lifetime and would positively affect their behavior and practice whenever they worked on an aircraft. However, that's not realistically feasible. The good news is that there are other ways for mechanics to learn and learn from others' mistakes. One of the primary ways is from reading NTSB safety alerts. Another good way to learn from others' mistakes is to study accident reports.
So what you have on your seat is a DVD that has the full versions of the 5 videos. As Mike Hune mentioned, the one thing you can do is take a look at accidents. You can learn a lot from accidents. That's our basic process for what we learn at the NTSB. That's the basis for the recommendations that we come out with to improve safety. There's a wealth of material available on the NTSB website. Accident files are online, dockets are online, and that's been improving all the time. The dockets give you factual reports, interviews, photographs. Many people think that the one-page summary is all that you have available from the NTSB on an accident, but in fact, many of these dockets are inches thick. So I encourage you to take a look at ntsb.gov. You can download these and other safety alerts. You can download the videos. You can distribute the videos to anybody you'd like. The more the merrier. We certainly encourage that. So with that, I'll take some questions. Yes?
Of course, I've encountered difficulty with the flight service people. In making pilot reports, I've encountered difficulty with flight service people. It's a hassle to make a pilot report. It seems like they the person that's receiving it doesn't quite understand it, or because I have to repeat things about 4 times in order to get them to repeat it back and say, is this what you reported? And I have to say yes, but it took 4 times to get there, and it's very difficult. Another thing I would like to see, as an instrument pilot that has a capability of flying at higher altitudes with turbocharged, turbo-normalized airplane, I would like to see the TOPS reports from airliners that are leaving airports, and they always go out on, eventually get on top. But very seldom do you ever see a TOPS report except from maybe a GA pilot.
I've experienced some of the same difficulty giving pilot reports in the past. What we found when we dug into it was there are meteorologists who love to have pilot reports. Then there are the folks in the middle who have to handle them who don't really understand the value of the pilot report. So part of our activity with regard to working the whole community, the ATC, the pilots, the National Weather Service, Flight Service, is to make everybody understand the dependency that everybody else has on moving this kind of information back and forth. AOPA has been pushing very hard on pilot reports for a long time. As far as top reports and so forth, I think that more use of the Center Weather Service, or Center Weather Advisories, or the Center Weather Service Unit may help here. Because these folks are co-located with the ARTC folks. They basically have direct lines into the various ATC controllers. You might try just asking for some TOPS information, see if you can get TOPS information on departures. A lot of information gets passed, particularly on turbulence. As you know, is when you fly cross country, the airlines pay a great deal of attention to turbulence because that's a ride comfort issue. But you'll also get good pilot reports on icing. But what we'd like to see is more pilot reports about just the general weather. And don't give up on trying to send pilot reports. You may just find a few of the flight service folks who don't really understand the value of it.
Concerning icing, I've been involved with icing. In fact, I lost an airplane due to icing. And the problem we have with icing is what the FAA's interpretation of the flying into known ice. They have a very broad application of known ice, and it could be even the fact that icing is possible in the flight briefing, which of course is not always the case. And I've flown in conditions where pilots 20 miles away from me were reporting icing conditions where I was having none whatsoever. But the problem I see with icing conditions is the FAA has a tendency to violate you if they know that you've encountered icing conditions, and even if you're doing whatever you need to do to get out of it, which is what I did. And I had a malfunction of the airspeed indicator. PDOT heater quit working in flight. It worked on pre-flight. But they gave me all kinds of grief over this situation, and the problem I see is the FAA is applying general icing conditions as being actual when they're not.
Yeah, I recognize that that's been a policy issue that's been interpreted and reinterpreted over the past several years. The current status of it, I don't really know. Again, the NTSB doesn't have any responsibility for enforcing regulations, fortunately, so we get to deal with the kinder, gentler side of the FAA. They're just between us kids, there isn't one FAA. So, any other questions? Thank you very much.
Again, thank you, Member Earl Weener, for the great presentation. Thank you.